given the sample that we have here, there is no sufficient evidence to support that the average order size for landing page A is significantly different from average order size from landing page B. So given this result, the website owner may want to come up with another version of the landing page to see whether there'll be a gain or lift in the metric of interest. And that's how you can apply independent t-test to do A/B test of websites.
In this next tutorial, we will apply t-test to determine if the process change implemented improved the order fulfillment pick rate.
For those who are involved in continuous improvement have one thing in common. The aim is to improve how things are being done. That means that one common phenomena in processes is that there is a way of performing a task and a new way of performing a task. In any change process worth measuring, it's important to determine through hypothesis testing whether there was a statistically significant change in the process. A common way to see if there was statistically significant change in the process is to use the paired t-test. In this example, we will consider picking, which is a process in order fulfillment. Now, suppose you manage the outbound department and picking was a process you managed. Now, imagine that your pickers are measured by the pick rate or the number of items picked per hour. Suppose also that you decide that as a team, you would improve the picking process with the hope of increasing pick rate with no change in labor. And now, after the process improvement, you have gotten these results. Now, since the measurement of pick rate is on the same individuals or same team members before and after, then paired t-test is indeed the appropriate hypothesis test to use in this example. So let us first check whether the variances before and after remained the same. So to do that, let's go to data analysis. Then let's look for F-test to sample for variances, then click OK. For variable 1, let's select everything under before up to the last team member J. Click this button. Then for variable 2, let's select everything under after up to team member J. Let's tick this option because we selected the column names, and then retain the level of significance at 5%. For the output range, let's just change this into, say, F1. Then click OK. Of course, since these measurements were captured on the same individuals for the same task or process, then expectedly the p-value for this hypothesis test is greater than 5%, which means that there is no significant difference between the variances before and after. Now let's proceed to performing the paired t-test. So again, under data, click data analysis, select paired two sample t-tests, and click OK. For variable 1, let's select everything under before up to the last team member. Then everything under after up to team member J. For the hypothesized mean difference, let's just set this to 0, which means that our alternative hypothesis is that the average before is greater than not equal to or significant or is significantly different from the after. Make sure we tick labels because we selected the column names. Keep this same level of significance. And for the output range, let's just put the result table beside the f-test. Click OK. So here you can see that for both the one-tail and the two-tail test, both are less than 5%, which indicates that the process improvement or the process change resulted in a statistically significant change in the pick rates of the pickers and after. Now, recall that for the one-tail test, the alternative hypothesis here is that the before, or rather the after, the pick rate after is greater than the pick rate before. And the p-value is less than 5%. So given the results of the paired t-tests, we can say that the process change resulted in an improvement in the pick rate of your team. And that's how you can perform paired t-test to measure the improvement of the process change you've implemented.